Swayam Prabha. Digital India. Educated India.
Hello, welcome to Basics of Noise and its Measurement. This is the fourth week of this course, and what we are going to cover in this particular week is a lot of stuff about microphones. So in any sound related measurement, the most important instrument in most of the cases is the microphone. In during last week we had seen that how we can use an impedance tube which is mounted with a travelling microphone, and the information which we get from this travelling microphone can be used to figure out the value of impedance. But then we do not measure impedance directly, we measure pressures, and from the information which we extract from pressures, we ultimately are able to figure out what is the impedance of the material which is positioned at the end of the impedance tube. So this is one example, but essentially what I am trying to say is that microphone is perhaps the most important instrument which is used in an extremely large number of sound related experiments. So this week we will purely focus on what is a microphone, how does it function, what types of microphones are there in the marketplace, how do we select a microphone, what is the sensitivity of a microphone, what are the different considerations which we have to factor in as we go ahead and select a microphone which meets our applications, and then some information also about instruments which are attached to the microphone. For instance, a preamplifier, what is it, what does it do, what is its importance, and so on and so forth. So that is what we are going to discuss today, and as we walk through this course during this week, we will also see actually some of the physical instruments, how they look like, so that you get a better feel of what kind of microphones are there in the marketplace, and some more information about that. So that's what we are going to do this week, and specifically in this particular lecture, what I will be discussing with you is how do we classify microphones. So this week, and probably also this lecture, and maybe also in the next lecture, we will discuss about different classifications of microphones. I think that's important to know, because a lot of terminology which goes with usage of microphones is associated with this classification. So once you have a feeling of how things are classified and what is the fundamental behind its terminology, it will be helpful for you when you go out in the field and do some sound related measurements. So what we will discuss is classification of mics. But before I dig deeper into it, in a lot of places you will see there is a symbol for a microphone. For instance, there is a symbol for resistor, and the symbol for resistance is like this. There is a symbol for inductor which is like this. There is a symbol for capacitor which looks like this. Similarly, there is a symbol for microphone, and the symbol for microphone it looks like this. Okay, so that's how at least in the electrical world this is the standard symbol for microphone. Now what we will do is we will start the classification, and we will classify these microphones in a couple of ways. The first basis which we will classify these will be based on technology. So based on technology, based on operating technology. So what we are going to do is we will classify based on how they actually work. So the first type of microphones which came into existence, that was way back in time, in late 1800s, and they were known as carbon microphones. Okay. So actually there were two people who invented them independently. One was Hughes and the other inventor. So both of them invented this microphone independently. They did not talk to each other, and actually there was a lot of confusion and also to some extent some bitter and acrimonious fight between these two inventors in terms of who was the first person to get to these microphones. But regardless, how do these work? So what happens is that you have, let's say, a diaphragm. So this is a very coarse schematic diagram. So this is some sort of a chamber, and here you have a very light metallic or some sort of a diaphragm. Okay, and inside this, so this is your chamber, which is covered by some metallic thing, and there is some sort of an insulation here, so that this green diaphragm, it actually does not touch the chamber. And in the chamber what we have are a lot of loosely packed carbon particles. So that's your diaphragm. That's some sort of a chamber's enclosure, and in the chamber we have carbon particles, and this is loosely packed. Okay. So what we are interested, at least in context of this particular thing, is we measure the resistance between this chamber's enclosure and the diaphragm, and because the diaphragm is not directly connected to the chamber, so all the current actually flows through these carbon particles, and the resistance of this. So now if you have the sound, let's say your sound is coming like this, and sound comes and it hits the diaphragm, so it pushes the diaphragm inwards, or if it's so the diaphragm moves in and out based on the pressure, whether it's above atmospheric or below atmospheric, and as a consequence of this pressure, the resistance of this graphite particles, because they are loosely packed, so when they come closer, resistance goes down, and so on and so forth. So the resistance modulates, so the current also which flows through this whole setup, it changes. So you sense the change in resistance or through sensing current or the voltage difference across it, and that you convert it into SPL. So change in resistance, that is mapped into SPL. Okay. So this is so that's why these were known as carbon microphones, and they were based on the resistive principle. So they were based on, so they were like resistance mics. The fundamental thing, property which was varying here was the resistance of the system. So that's why some of these microphones, sometimes people also call them as resistance microphones, and they were very widely used in past. So especially in the old style of telephones, where you would have this rotating dial, and so those types of telephones, or some earlier microphones, or microphones which were earlier used in broadcasting stations. A lot of these microphones, they were actually using these carbon microphones, but they were not so much used for measuring sound. So they were used to capture sound for communication purpose, but not for scientific and instrumentation related or related purposes. So this was perhaps the first category of microphones which came into existence. Then later people developed another class of microphones, and these were known as capacitor mics, or some people call them as electrostatic mics. Electrostatic mics. And then there was a third term for these were known as condenser mics. And most of the microphones which we use in modern days, a very large number of modern microphones, they belong to this particular category. Capacitor mics, electrostatic mics, condenser mics, all of these things, they mean more or less the same thing. The fundamental principle is that you have two plates. One plate does not move, the other plate is extremely close, and both of these are very close to it. So they are like two metallic plates, and there is some air between these two, and one does not move, the other one is susceptible to motion. So that's like your diaphragm, and when sound hits it, the second plate comes closer to the first plate, so the capacitance changes. So in the first category of microphones, we were sensing the change in resistance. In this category, we are sensing the change in capacitance. Now we do it in several ways, and that's why there are several categories of these capacitor microphones. But that's the fundamental principle, that it's change in capacitance that causes change in either current or voltage or whatever, and we sense this change in capacitance, and that is something which we convert into voltage or more appropriately sound pressure level. So this is the second category. Now this class of microphones, we can have several classes of this. One is DC biased, direct current biased microphones. Okay. So what is there? So in this, what you have is, let's say you have one plate. So let's say this is my reference plate, and then the other plate is your diaphragm, and what happens is that these two plates are essentially having a constant or more or less constant voltage across them. So let's say I put something like plus 400 volts across these. So there's and it's a DC voltage. Okay. So once this is there, then the charge, the capacitance across these two plates can be calculated in terms of charge which is accumulated on the plates divided by the voltage across the plates. So this charge is there. Okay. And because and this charge does not change a whole lot. Okay. Now once, so suppose you have again some sound pressure wave which comes and hits the diaphragm, then the distance between these two plates, it changes, and we know that this capacitance is also nothing but area of the plates times permittivity constants divided by distance between the two plates. Okay. So as distance changes, capacitance changes, because of this charge changes, voltage, the bias voltage is more or less constant, doesn't change a whole lot. So essentially what I do is I am trying to sense the change in charge, and from that change in charge I am able to calculate the change in capacitance, or I can also map it to the change in sound pressure level. So that's why this thing is known as DC biased type of capacitor microphone or condenser microphone. Then there is now this category of microphones. It works fairly well for low frequencies to somewhat moderate frequencies when we are trying to capture. And for a little higher frequencies, what people have developed is another category of microphones known as RF, that is radio frequency or high frequency condenser microphone. Okay, so this is the second category. So what happens in this case? So in this category, so in the first case we were applying pretty constant DC volt bias voltage across the two plates. Here we are having a RF or a radio frequency oscillator as a source, and essentially the aim here is not so much to charge the plates, but again because of change in capacitance, the current which flows through the system, because now we have radio frequency or some alternating excitation across the plates, so current also changes, and that is sensed, and the changes in that are sensed, and through that we are able to figure out what is the SPL. So this is the second category of microphone. Then we have valve mics. Valve mics. What are these? They are essentially same as these earlier types of microphones which we have discussed, but the only difference here is that the preamplifier or some amplifier or amplifier, but mostly it's at the preamp stage, they use, instead of transistors and modern electronics, they use valve tubes. So again, this is a little obsolete technology, so we don't have to worry too much about it, but just for purposes of completeness, this is the third type of capacitor microphone which you may hear about as you explore these microphones. And then there is something called an electret microphone. Now this is extremely popular, and it has some very powerful advantages. Now what is electret? So electret is essentially a type of material, okay, which stores some sort of a permanently some charge on it. So some of these types of so it could be something similar to ferromagnetic material, something like that. How is this done? So what people do is, so in this DC biased microphones, you are applying some external DC voltage to have a charge on the system. But in electric, you don't have any external DC bias, but rather there is physical charge actually which is deposited on the diaphragm. And how is it done? So some special materials, some special types of plastics or especially formulated materials, what they do is they have a very thin sheet of it, and just as in ferromagnetic materials there are dipoles which get oriented with respect to the direction of magnetic field. So these materials have similar characteristics. So what you do in these materials, you heat them and at a elevated temperature these electric charges can get oriented, and then at a heated stage, you have a very thin sheet of this material. At a heated state, you subject them to some intense fields, and what happens is, as a consequence, these charges accumulate in a particular direction, and then they get concentrated and they accumulate and orient in a particular direction, and they are, let's say, aligned, and they get deposited in a particular direction, and then you cool it to lower temperature. So these charges, they get something like frozen in the overall material, and they cannot run away easily. And then you cover this thin sheet of electric material with some other layers for protecting the thing and stuff like that. So now what you have is there is a charge deposited on this thin sheet, and because you are using this electric material, it's known as an electret microphone. Okay, so this is an important thing to note. And then when you have two of these sheets very close to each other, charge is already there, so there is also a voltage difference across the two plates, and then when you move the microphone closer or it moves out, then there is change in voltage. The charge is more or less constant, and that change in voltage can be sensed. It can be sensed using electronics. So this is what electret microphone is all about. Where do we use these electret microphones? Most of the microphones which you will see nowadays in day-to-day applications, your cell phones, laptops, a lot of desktop applications, maybe even this particular microphone which I am having on my shirt, it may be of electret type. A very significant advantage of these microphones is that in this DC biased, for instance, you have this charge, but if you have a lot of humidity, there could be leakage of voltage and charge to the outside world. But here, because the charge is kind of locked in, it has nowhere to go. So these are fairly stable systems over a period of time, and they don't leak very easily. They are more stable, they are more resistant to humidity and environmental changes, so they are more stable systems. However, earlier when these were invented, at that time the quality of these microphones in terms of their linearity and frequency response, it was not that great. What do we mean by linearity and frequency response? We will discuss that maybe a couple of days later. But in a broad sense, for instrumentation and for purposes of measuring noise or sound, they were not very viable candidates because they were not very predictable in their response or not very well behaved in their response. But over a period of years now, they have become extremely good, and a lot of times we actually use these types of microphones to measure sound. And lot of times these microphones are also known as pre-polarized microphones. See, here we need a polarizing voltage in case of DC biased. Here we don't need any external polarizing voltage. So that's why they are known as pre-polarized microphones. So this is a very popular category, and increasingly it is also being used for measuring noise, recording noise, and doing analysis, not just for entertainment purposes these mics are used, but they are also being increasingly used for scientific computation and scientific measurement of noise. So this is the second category of microphones, and we will continue this discussion in the next lecture. But what we have captured today are two categories: capacitor based systems and resistance based systems. And we will continue the discussion in the next class. Thank you very much, and look forward to seeing you tomorrow. Thanks.